Hi there. Let me do the second example with you. So these are the data that represent the difference between the actual high and the predicted or forecast high 5 days in advance. So if you recall, when we used these data previously, there was a lot more variability in the errors in prediction 5 days in advance compared to 1 day in advance, and we're certainly going to be able to see that here in just a moment. So again, we need to find the 5-number summary. So the minimum is -14. The median, again, is going to be the average of the 15th and 16th observations. There are 30 total. So there is no middle observation. The median would be here, the average of the 15th and 16th observation, but the average of -1 and -1 is just 1. So there is the median, -1. The average of -1 and -1 is just -1. So here's the maximum at 9. So next we have to find the Q1, that is the middle of the lower 15 observations. 1, 2, 3, 4, 5, 6, 7. Here is Q1. There should be 1, 2, 3, 4, 5, 6, 7 above it. Good. And correspondingly, here is Q3. So the lower quartile Q1 is at -4. The upper quartile Q3 is at +4, and now we have everything we need in order to create our plot, so we should title it. These are forecast errors, 5 days in advance. So here we have to go from -14 all the way to 9. So I have to be a little bit more careful graphing this, so I'm going to have to let my units here, let's say we put 0 here in the middle. In order to accommodate these larger values, I'm going to have to go by 2s. So it's important to always label your scale. 2, 4, 6, 8, -2, -4, -6, -8, -10, -12, and -14. So because we're using a different scale on example 1 versus example 2, you can't directly compare them in order to consider the variability. You're going to have to look specifically at the values for the range and for the IQR in order to see the comparison in variability. So the minimum, and again, we'll start with the box, the median is at -1. Halfway between the 0 and the -2. Q1 is at -4. Q3 is at 4. So here is the box. And again, I'm going to work in pencil to put my whiskers in. We have a maximum at 9. So again, we might have outliers, so we have to allow for that. And we have a minimum at -14. There we go. So here is our box and whisker plot. Now, I can already tell that we don't have any outliers here, and we're going to verify it numerically. But look, if you consider this, there are the span right here. If you increase that span by 50%, so literally, here is the span that represents the IQR between Q3 and Q1. If I increase it by 50%, if I take that distance and add it to Q3, way up here is going to be the upper cutoff for outliers. Well, clearly the maximum doesn't get close to that. Same thing, if we take this span, if we increase it by 50%, if we subtract that from Q1, again, notice the minimum is at -14. The cutoff for an outlier on the low side is going to be below that. So I do want you to calculate the IQR. Again, that's the difference between Q3 and Q1. 4 minus -4, that's 8. And I want you to use that to calculate the lower and the upper cutoff to verify that we really don't have outliers. So the lower cutoff would be Q1, -4, minus 1.5 times the interquartile range of 8. So that's going to be negative 4 minus 12. That will be at negative 16. So notice I don't have any outliers on the low side. I would have to be below negative 16 in order to have an outlier, and my minimum's at negative 14. So for the upper cutoff, we have Q3 at 4, and I'm going to add 1.5 times the interquartile range. So that's going to be 4 plus 12. That's 16. So 16's way up here. So I don't have any values that will exceed 16. My maximum is 9. So understand, the reason why we don't have outliers in example 2 is because the 5-day out forecasts have more variability. When you allow for an additional 50% of variability above Q3 and below Q1, you're magnifying that variability. You're saying, wow, there's already so much variability in the interquartile range. I have to allow for quite a bit of variability above Q3 and below Q1 before I can believe that I have an outlier or not. So this is the modified box and whisker plot for example 2.